Okay, saya akan share screen. Okay, boleh nampak tak screen?
Nampak madam?
Yeah. Okay, Assalamualaikum and good morning to all of you. Okay, today we will learn a new chapter, which is chapter 4, okay, the vector space. Okay, today we will focus on the first subtopic for chapter 4, okay, 4.1, okay, the vector, the introduction of vector. Okay, learning outcome in this subtopic. Okay, there are 4 learning outcomes. At the end of this study, okay, you should be able to recognize a vector. Okay, what is the term of a vector and the notation of a vector? Okay, the second objective. Okay, perform the basic operation on vector. Okay, there are 3 basic operation on vector. Okay, addition, scalar multiplication and subtraction. Okay, number 3, find a unique vector. And the last one, find the dot product and the angle between two vector. Okay, this is the application of the vector. Okay, using dot product and angle. So there are 4 learning outcome in this subtopic. Okay, now we look at the introduction to vector. Okay, this table illustrate the difference, okay, between vector and scalar. Okay, so the characteristic for a vector, okay, the vector involve magnitude, or we can call it length and direction. Okay, for a vector, it has magnitude and direction. Okay, for example, we have the velocity and force. Okay, it is the example for vector. And okay, and for scalar, it only has magnitude. Okay, we only can calculate the length of a scalar. It has a direction lah. For example, we have temperature and length. And also scalar, we also has this one, speed. Another example for scalar. Okay, the vector. Okay, in this topic, we focus on the vector. Okay, the vector, okay, use the notation of lowercase letter. Okay, this one, V is equal to AB. Okay, vector U and V are said to be equivalent or equal if they have the same length and direction. Okay, same length and direction. So it is equal vector. Okay, so in this figure, it has, okay, A is the initial point and B is the terminal point. Terminal point or end point. Okay, look at the component vector. Okay, let V is equal to AB. Okay, V be a vector component of point A and B. So vector V is equal to, okay, AB. So we find the component of vector V is equal to B minus A. Okay, the terminal point minus, okay, this one B is terminal point or the end point. Okay, minus the initial point. Okay, so y1 minus x1, y2 minus x2. We want to find the component of a vector. Okay, look at example 1. Okay, find the component of a vector PQ. Okay, with the initial point of P 2 -1 and Q 7 -5. Okay, so we want to find the vector PQ. So in this case, okay, vector Q minus vector P. Okay, vector Q, this one, vector Q is the end point or terminal point. Okay, minus the initial point. Okay, 7 minus 2 is 5. -5 minus -1 is -4. So vector PQ is equal to 5, -4. Okay, boleh faham? So if we want to find the vector QP. So how to find the vector QP?
OP tolak OQ.
So P minus Q. Vector P, OP minus OQ. So P2 -1 minus 7 -5. So -5, 4. Kena tengoklah dia punya ni. Okay, now we look at the basic operation on vector. Okay, first we look at the vector addition. Okay, plus symbol. Okay, if U and V are two vector, U and V is obtained by positioning the initial point of V at the terminal point of U and join the initial point of U to the terminal point of V. Okay, look at this equation. Okay, U plus V is equal to, okay, this is vector for U, U1, U2, okay, plus V. Vector V is V1, V2. So U plus V is equal to U1 plus V1, okay, and U2 plus V2. We just add these two vector lah, U plus V. Okay, this is the illustration for vector U plus V. We will look at the example later. Okay, the second operation on vector is the scalar multiplication. Okay, multiply a vector with a scalar C such that if C is equal to -1. Okay, for example, we have the scalar is -1. C is the scalar. Okay, then Cu is equal to -U. Means -1 times U lah. -1 times U. Vector U. So is equal to, for example, U1 and U2 is a vector in the opposite direction of U. So opposite direction, it has a negative sign, opposite direction. And is of the same length as U. Okay, this vector is called the negative vector of U. Okay, this one U is the same direction of U. Okay, 2U is the same direction of U, but 2, it has two magnitude of 2. 2 times U lah. Ni 3 times U. And then this one, the opposite direction, -3U. This also the negative direction. Okay, third operation on vector is the vector subtraction. Okay, the vector subsection between two vector u and v is defined as u minus v. Okay, this one is vector u1, u2 minus vector v, v1, v2. So it's equal to u1 minus v1, u2 minus v2. Okay, this is the summary of the basic operation on vector 2 space. Okay, vector 2 space, we have two component lah, u1 and u2. Has two component. For example, vector u, so it has two component, u1, u2. Okay, this is for 2 space. If the vector has 3 space, so we have 3 component lah, u1, u2, and u3. 3 space. Okay, 3 space also has the same basic operation as the vector into space. Okay, vector addition u plus v is equal to u1 plus v1, u2 plus v2. And the vector multiplication with scalar. Okay, so cu is equal to cu1, cu2. And vector subtraction is equal to u1 minus v1, u2 minus v2. Same lah as the 3 space. For example, 3 space for vector addition. So we have u plus v is equal to we use these 3 component lah, u1, u2, u3, plus v1, v2, v3. So it has u1 plus v1, u2 plus v2, and u3 plus v3. Okay, this is the example for vector in 3 space. Okay, same operation as the vector multiplication and subtraction. Okay, now we look at the example 2. Okay, given the vector u, okay, the vector u is the vector in 3 space. The vector in 3 space. And given the vector v also in 3 space, okay, solve the following. Okay, negative u plus v. Okay, you have to find the negative of u. So negative of u is 4, negative 3, negative 1. Okay, and then plus v. Okay, so it will have 4 plus negative 2 is 2, negative 3 plus 1 is negative 2, negative 1 plus 3 is 2. Okay, b, 2u minus v. Okay, first you have to multiply with scalar 2. So we have this vector, new vector 2u. So negative 8, 6, 2. Okay, then minus vector v. So we have negative 8 minus negative 2 is negative 6. Okay, 6 minus 1, 5. 2 minus 3, negative 1. Okay, I will give you another example. Okay, in tutorial, you can do it yourself. Okay, for this tutorial, this is another notes in the Google Classroom. Okay, you can do it on your own lah untuk ni homework. Okay, number 1 and number 2. Okay, this one is vector in 3 space. Okay, number 2, question number 2 is vector in 5 space. R5. Same, we use the same operation lah. Okay, untuk ni boleh try sendiri nanti untuk tutorial. Okay, now we look at the properties of basic operation on vector. Okay, theorem, properties of basic vector operation. Okay, let U, V and W be V vectors and M and N be scalar. Okay, there's a new vector W. There are three vector U, V and W, and also two scalar M and N. Okay, so there are 8 properties. Okay, there are 8 properties. Okay. Number 1, U plus V must be equal to V plus U. Okay, number 2, U plus V plus W is equal to U plus V plus W. Okay, number 3, U plus 0 vector. Okay, this is a 0 vector. Is equal to 0 vector plus U is equal to U. Okay, number 4, U plus negative U, which is the opposite direction of U, is equal to 0 vector. Okay, number 5. Okay, M and N is a scalar. So M times N U is equal to Mn times U, vector U. We can multiply this scalar M times N. Okay, number 6. Okay, M times U plus V is equal to Mu plus Mv. And number 7, M plus N. Okay, M and N is a scalar. Times U is equal to Mu plus Nu. And the last one, 1 times U in the subtopic 4.2. You have to prove this property. Okay, the left hand side is equal to right hand side. Okay, the next subtopic we will learn later how to prove this property. Okay, ada soalan tak? Untuk ni, property of basic vector.
Ada.
Ada.
Ada ni kita akan tengok untuk next subtopic. Ni just introduction lah. Okay, next is the vector norm. Or we call it vector norm is the magnitude of vector. Magnitude or length of a vector. Okay, the length of a vector U is called the norm of U. Norm of U. Okay, is denoted by this symbol. Okay, if U is equal to U1, U2, then okay, we find the magnitude or norm of vector is equal to the square root of U1 square plus U2 square. Okay, is the magnitude of U lah, or norm or length. Okay, we use this formula. You have to remember this formula. So is this the length of magnitude? Normally we call it length or magnitude of a vector. Okay, a vector of norm 1 is called a unit vector. Vector with magnitude 1. Unit vector is vector with magnitude 1. Magnitude 1. Magnitude 1. So we call it, the special name is a unit vector lah. Magnitude 1. Okay, the unit vector that has the same direction as u is equal to u over the magnitude of u. Okay, vector that has the same direction. If the vector that has the opposite direction, so the unit vector is equal to negative u over magnitude of u. It is, this one is for the opposite direction. Negative u over magnitude of u. Okay, if P and Q are 2 points in 2 space, then the distance D between them is the norm of a vector is given by, okay, this formula. PQ, we have 2 points into space, so equal to the square root of x2 minus x1 square plus y2 minus y2 square. Okay, this one is for scalar. To find the magnitude for Ku, K is a scalar. K is equal to the absolute of K, scalar 2 lah, times the magnitude of U. Okay, always positive value lah. Positive, the length is always positive. That's why we use the modulus. Okay, look at example 3. Okay, given the vector u is equal to negative 4, 3, negative 1, and v is equal to this vector, the vector in 3 space. Okay, solve the following. Okay, determine whether the vector u is a unit vector or not. Okay, what is the unit vector? Sebelum ni. Unit vector is the
Vector with magnitude 1.
Vector with magnitude 1. Magnitude 1. So you have to prove lah this magnitude, whether it is 1 or not. So we find using this formula, the magnitude is equal to the square root of so ni negative 4 square plus 3 square plus negative 1 square. Which is equal to square root 26. It's not equal to 1. So it is not a unit vector. Not a unit vector. Okay, if not, find a unit vector in the same direction as u. So for the unit vector, we have to find, okay, u over the magnitude of u. This one, unit vector. The same direction. Soalan dia same direction kan? Same direction. So positive lah. U over magnitude of u. So the vector u is negative 4, 3, negative 1 over the magnitude of u. The magnitude of u is square root 26. We have found it before lah. So the magnitude is equal to, okay, negative 4 over the square root 26, 3 over square root 26, and negative 1 over square root 26. So it is the unit vector. So nanti ni dah unit vector lah kan. So kalau you all find the magnitude of this unit vector is equal to 1. So the magnitude is equal to 1. Okay, so question B. Okay, find the magnitude for V, vector V. Just square root of negative 2 square plus 1 square plus 3 square is equal to square root 14. Okay, question number C. Okay, the magnitude of U plus V. So first you have to find the vector U plus V. The first step, you have to find the vector U plus V. Okay, you have to use the operation addition. Okay, so the vector is equal to negative 6, 4, 2. Okay, then find the magnitude. Okay, using formula, this formula. So it's equal to square root 56. Okay, ni question C. Boleh faham?
Boleh, madam.
Yes. Okay, question D. Okay, find vector W given that the magnitude of W is equal to 10 and W has the opposite direction. Opposite direction as U. Okay, so first we have to use the formula for unit vector. Unit vector. Unit vector U over the magnitude of U. So the unit vector for U is equal to the unit vector for W. So W over the magnitude of W. So given that the magnitude of W is equal to 10. Ini soalan kan? Okay, so W over magnitude of W is 10. So it's equal to the unit vector for U. Okay, the question is the opposite direction. Question opposite direction. So you have to put the negative sign in this U. Negative sign. So negative U. U is negative 4, 3, negative 1. So over the magnitude of U is square root 26. Okay, then we bring this 10 into the right hand side so that we can find the vector of W. So W is equal to, okay, this one, 40, negative 30, 10 over the square root 26. Then you have to solve this vector W lah. So it's equal to 40 over square root 26, negative 30 over square root 26, 10 over square root 26. Kita kena buat equal lah, equal to the unit vector ni. Untuk cari the new vector for W. Okay, ada soalan tak ni? Okay, untuk yang ni cuba. Okay, this one question ni in notes. In other notes tu, okay, example 1. Okay, given the vector U is equal to vector into space. Okay, determine whether it is a unit vector You have to prove lah unit vector is equal to 1. If not, find the unit vector in the opposite direction as u. Okay, cuba kita try yang ni. So, find the vector of u. Okay, semua boleh try. Is equal to 5 kan? 5 is not equal to 1. So, it is not a unit vector. Okay, if not, find a unit vector in the opposite direction. Okay, question opposite direction. So, negative u over the magnitude of u. So, equal to negative 24.3. Okay, dapat tak sama? Okay. Okay, number 2, find the vector x which has the magnitude of 10 and in the opposite direction of u. Same as the example, the previous example, D. Number 2. So we have to find the magnitude lah, x, the unit vector x over magnitude of x is equal to u over magnitude of u. Okay, so just substitute x over, given that magnitude of x is equal to 10 and u, vector u, it is opposite direction. So negative lah, negative sign. So yes, negative 4, 0, 3, negative 5 over, okay, magnitude of u. You have to find the magnitude of u lah kat sini. Sixteen plus 0 plus 9 plus 25. Okay, berapa magnitude of u?
Say 50.
Set 50. Okay, dapat lah ni. Ya, perlu pecahkan lah yang kat sini. 0, 50 over 50, set 50. Final answer ni. Okay, ada soalan? Ada soalan tak ni?
No, madam.
The madam.
Kejap ni saya tu nak saya nak ni. Okay, sorry. Okay, boleh nampak tak skrin?
Boleh, madam.
Boleh, madam.
Okay. Okay, next is the dot product and sum of its application. Okay, let the angle between U and V be theta. Okay, where theta is less than or equal to pi. Okay, pi is 180 degree and greater than or equal to 0 degree. Okay, normally in this case, okay, we use degree lah, form in degree. So in calculator, you have to set the mod in degree. Calculator you perlu set lah mod degree. Kena tukar lah. Kena make sure mod dia in degree D. Okay, so for acute angle, you have to know what is the acute angle, obtuse angle and right angle. Okay, for the acute angle, okay, the theta is less than 90 degree. Okay, so we convert this, okay, pi over 2 is 90 degree. 180 over 2. That is equal to 90 degree. So theta less than 90 degree. For acute angle less than 90 degree. Okay, for obtuse angle, okay, theta greater than 90 degree. Okay, obtuse angle. And for the right angle, theta is equal to 90 degree. You have to recognize that what is the acute angle, obtuse angle and right angle. Okay, and then, okay, what is the dot product? Okay, let U is equal to, okay, vector in n space, U1, U2, okay, until n, Un, and V also vector in n space, okay, V1, V2 until Vn, be any two non-zero vector in n space, Okay, then the dot product between U and V is a real number. Okay, defined as okay, U dot V is equal to U1 times V1 plus U2 times V2 plus, okay, until Un times Vn. It is the real number. Okay, U dot V. This is the dot product. So you have to know the formula for dot product. So what is the application for the dot product? Okay, theorem property of dot product for any non-zero vector u, v, w and c, b scalar. Okay, properties of dot product. Okay, u dot v is equal to v dot u. Okay, number 2. involves scalar, C times U dot V is equal to CU times V. Okay, is also equal to U dot product with CV. Okay, this one is dot product. Dot product. Dot product. Okay, number 3, U dot V plus W is equal to U dot V plus U dot W. Okay, number 4, U dot U is equal to magnitude of U square. Okay, number 5, U dot U is greater than 0 if U is not equal to 0. Okay, number 6, U dot U is equal to 0 if U is equal to 0. Okay, U is equal to 0 means the 0 vector lah. Kat sini, 0 vector. 0 vector. And this number 5, U is not a 0 vector. Not a 0 vector. Okay, definition of dot product. If U and V are any two vector in the two space or three space, and theta is the angle between U and V. Okay, then, okay, the magnitude of U times the magnitude of V times cos theta. Okay, if U is not equal to 0 and V is not equal to 0 vector. Okay, the angle is equal to 0 if U is a 0 vector and V is 0 vector. Okay, so this is the formula to find the angle between vector U and V. The angle theta, okay, between U and V. So we want to find the angle. This formula is for angle. Okay, so theta is equal to cos, the inverse cos times U dot V over the magnitude of U times magnitude of V. So in this numerator, you have to find the dot product lah, dot product between U and V. Okay, where the theta is less than or equal to 180 degree or pi, greater than or equal to 0. Or we can use this formula lah, cos theta is equal to the dot product U between U and V over magnitude of U times magnitude of V. Okay, this formula can only be used to determine the angle between two vector. Only two vector, U and V. Okay, also we can find the types of angle between two vector based on this theorem. Okay, If u dot v is greater than 0, so it is acute angle. U dot v greater than 0, it is acute angle. If u dot v less than 0, it is obtuse angle. Ini less than 90 degree lah. Acute angle, theta less than 90 degree. For obtuse angle, theta greater than 90 degree. And for the right angle, if u dot v is equal to 0, right angle is equal to 90 degree. You can also use this formula u dot v ni semua. If greater than 0, so acute. Less than 0, obtuse. Is equal to 0, it is right angle. Okay, so and the last application, okay, is the definition of orthogonal vector. Okay, the two vector u and v are said to be orthogonal if u dot v is equal to 0. So orthogonal if u dot v is equal to 0. Okay, that is the angle between u and v is a right angle. U and v is the right angle. Right angle is 90 degree. UV. So it is right angle, and the proof for right angle, or we call it orthogonal lah, orthogonal. If u dot v is equal to 0. Okay, now we look at example. The product and its application. Okay, check. Let me check ni. Okay, find the dot product of this. Okay, look at example. Okay, A. Boleh nampak tak ni?
Boleh, madam.
Boleh? Okay, u dot v. Okay, u dot v. So 1, okay, u dot v is equal to 1 times negative 2, okay, plus 0 times 4 plus 3 times 1. That is equal to
1.
okay, yang ni dalam notes yang last last notes, last 4.1.2 lah, dia punya example ni. Is equal to 1. Boleh
Boleh.
Okay, so yang lain ni boleh try lah sendiri, homework or tutorial. Okay, ni ada dalam Google Classroom. Notes yang last sekali tu. Okay. So, okay, look at this example. Okay, how to find the angle. Okay, between UV. Okay, example 1, find the angle between U and V. U and V, vector U and vector V. Okay, so to find the angle, okay, formula apa yang kita perlu gunakan? Formula ni kan tadi. Theta. Ataupun you boleh guna ni dulu lah. Cos theta is equal to u dot v u dot v divided by magnitude u times magnitude v. So yes, cos theta equal to u dot v over magnitude u times magnitude v. Okay, so first you all perlu tahu u dot v lah, u dot v. Okay, question A, find the angle between u and v. So u dot v is equal to, okay, 1 times 3 plus 2 times 74 plus 3 times 2. Okay, berapa u dot v?
70.
Okay, 17. Okay, and then find the magnitude of u and v. Okay, magnitude u. Okay, using the previous formula lah, how to find the magnitude of u. So 1 square plus, okay, negative 2 square plus 3 square square root n. Okay, equal to apa? Magnitude of u.
Set 14.
14. And magnitude of v.
Set 29.
9 plus 16 plus 4. Square root 29. Then you boleh masukkan lah. Cos theta is equal to 17 over square root 14 times square root 29. Boleh tekan calculator. So kita nak cari theta kan kat sini kan. Theta so equal to inverse. Okay, dapat berapa?
32.47.
32.47. Kena make sure tukar dalam watt degree kat sini calculator. Kalau awak guna watt radian tak dapat jawapan lah. 17 over. Kena tukar watt degree yang kat atas tu. Ada tak siapa yang tak tahu nak tukar? Okay. So it is apa? This angle is acute angle. Okay, dia tak ada suruh determine the types kan. So this is acute angle, tak apalah. Okay, B. Okay, magnitude V dapat berapa?
Set 29.
Oh, V tadi dah kira V dah kira. Okay, magnitude W.
Set 6.
W. So 1 plus 4 plus 1. Square root 6. Okay, then masukkanlah dalam formula dia kan. So cos theta equal to cos. Okay. V dot W dapat apa? V dot W.
Negative 3.
V dot W is equal to
Negative 3.
negative 3. So negative 3 over square root 29 times 6. Okay, akan dapatlah ni kan 103.15. Okay, dapat tak?
Dapat.
So it is obtuse angle. Okay, C. C cari cuba cari. Okay, U dot W. U dot W dapat berapa?
0.
Okay, dapat 0. So 0 over something is 0. So 0 lah kan. Shift cos inverse 0 is equal to
90.
90. Kat sini C dapat cos inverse 0 kan. So equal to 90 degree. So it is obtuse, it is right angle. Right angle. Okay, yang ni you boleh try sendiri cari ni. Determine the value of C so that the angle between U and V is equal to pi over 4. Boleh cek sini So the answer is equal to C equal to 0. Okay, kita tengok contoh yang tadi tu untuk ni. To determine the types of angle between two vector. Okay, using dot product kat sini without calculate the angle between two vector. We just calculate the dot product between these two vector. We just want to find the types of vector. Okay, either the types is acute angle, obtuse or right angle. So kat sini U dot V. Soalan dia kan, determine the types of angle between the following pairs of vector. So you all tak perlu cari dia punya angle lah. Just tahu dia punya types of angle je. Macam tadi kita nak tahu dia punya theta dia berapa kan. Okay, yang ni kita nak tahu types je. So we find U dot V lah. U dot V. Okay, so berapa ni? 3 times -1 plus 4 times 2 plus 1 times 5. Okay, U dot V berapa? 10 kan? So 10 is greater than 0. So it is acute angle. Ni. Greater than 0. Ni saya highlight kan. Ni ingat dah ni. U dot V greater than 0. So it is acute angle. Okay, ni number 2 U dot V is equal to 2 times 4 plus 3 times 1 plus 1 times negative 3. Greater than 0. Okay, boleh faham?
Boleh.
Okay, last. Okay, are the vector U and V are orthogonal or not? Okay, proof for orthogonal. Definition for orthogonal apa dia? The two vector.
U times V equal to 0.
U, okay, good. U dot V, U dot V dia dot. U dot V is equal to 0. Proof untuk orthogonal. So U dot V is equal to 60 times -1 is equal to 0. So it is orthogonal. Since U dot V is equal to 0, explain. It is orthogonal since U dot V is equal to 0. So explanation kena explain lah. Ni untuk proof lah. Yes, number 2, find the value of C such that U dot V, U and V are orthogonal. Ni pun sama, you all perlu proofkan U dot V is equal to 0. So 3C times C plus -1 times 4 plus C times 1 is equal to 0. So 3C square minus 4 plus C. So you have to find value for C lah. This is quadratic equation. 3C square plus C minus 4 is equal to 0. Okay, solve this quadratic equation. So C equal to?
1.
Okay, 1. And C equal to?
Negative 4 over 3.
Negative 4 over 3. Okay. Okay, that's all for today. Okay, you can do the tutorial 4. Okay, tutorial 4 is based on past year question. You can do on your next session tutorial. For tutorial, let's try lah ni. 3, 4, 4A for the first subtopic. Try lah. Boleh try lah ni semua berapa. 10 soalan. Ya, 10 soalan boleh try. Nanti saya akan set lah dalam group tutorial Google Classroom. Soalan apa yang perlu you all submit. Okay? Okay, ada apa soalan tak? Kita dah habis untuk first subtopic lah.
Tak ada, madam.
Ada Okay, kalau tak ada, kita boleh stop sampai sini. Okay, so you all jangan lupa lah untuk klik attendance dalam future dan you all perlu bolehlah try lah buat kat sini ada soalan yang kita tak essay yang kita tak discuss tadi kan. Bolehlah try sendiri kat sini. Notes yang lagi satu ni, ni boleh try. Bolehlah cuba buat yang ni. Dan soalan tutorial 4A tadi. Mana yang tak buat boleh buat. 4A bolehlah cuba buat semua. Ni ni based on past year question. So dia ada marks kat situ lah. Okay, untuk ni chapter 4 ni akan ditanya dalam assessment 3 you all. Assessment 3 you all. Third assessment is an individual. So untuk chapter 4 akan ditanya dalam assessment 3 tapi tak akan masuk dalam final untuk yang ni. Chapter 4 ni tak masuk dalam final. Final hanya chapter 1, 2, 3, 5, 6. So chapter 4 ni walaupun tak masuk final tapi untuk third assessment tu banyaklah percentage dia 30%. So kena untuk yang ni baru first subtopic kan. Untuk second and third subtopic ni more kepada proven theorem. So yang tu pun nanti untuk next session kita akan tengoklah how to prove the axiom. Okay, kalau tak ada, kita stop sampai sini lah. Okay, terima kasih semua. Assalamualaikum. Jumpa lagi. Kalau ada apa-apa boleh WhatsApp.
Thank you, madam.
Thank you, madam.
Thank you, madam.
Okay, bye. Take care.
Thank you, madam.
Thank you, madam.